Good evening to all of you in India. Good morning to all of you in the US and everywhere else in the world, wherever you are. Greetings to all of you from the Tata-Cornell Institute at Cornell University in Ithaca, New York. It's a great pleasure for us to host this webinar on zero hunger, zero carbon food systems for India. The Tata-Cornell Institute has been working intensively over the past decade in looking at sustainable food systems that work at the nexus of agriculture productivity, nutrition, health, and increasingly environmental nexus. So that brings us to the topic of today. As we think about environment and agriculture, food, and environmental nexus, the topic, the really hot topic of the day is climate change and the impact of agriculture on climate change and also climate change's impacts on agriculture. And that's a topic that is extremely current, lots of discussions going on around the world and several summits in this area. And it's an area that the Tata-Cornell Institute has initiated a major effort, a 2-year effort looking specifically at how do you get to zero hunger while also trying to achieve a net zero carbon goal in food systems with a specific focus on India. And we will then pick a few states in India to go down further detailed examination on, and we'll talk about that as we go through this program today. So why are we interested in the issue of zero hunger and zero carbon? As we all know, India has made tremendous strides over the last 6 decades in hunger reduction. Yes, there's still hungry people, but imagine what the situation would have been like if we did not make the massive investments in agriculture technology, agriculture infrastructure, irrigation infrastructure, and overall investments in increasing food productivity. Those investments that came through the Green Revolution had enormous impacts on hunger reduction, but they also came at significant cost. They came at significant costs in terms of environmental degradation, loss in soil fertility, water table decline, biodiversity loss, etc. But it also resulted in significant increases in greenhouse gas emissions. Much of that agriculture strategy, which was focused on the big staples, intensification of rice and wheat systems, had the enormous positive impacts on reducing calorie hunger, but at the same time, increasing that trade-off associated with the environmental costs and climate costs for agriculture systems. Today, we are talking about doubling agriculture productivity, doubling farmers' incomes. And that's a laudable goal given the continued existence of hunger, the continued existence of rural poverty. But if we look at doubling hunger in a business as usual scenario, then one would anticipate that this trade-off between hunger reduction and environmental degradation, greenhouse gas emissions would increase substantially. So what we need to think about is how do we get to a zero hunger goal while at the same time being able to achieve or make progress towards a zero carbon goal. And I think that's what this webinar is going to talk about, and this webinar will try and address. As we think about this, as we think about that nexus of hunger and carbon, I think there are also enormous opportunities for getting there. There are opportunities because as we think about hunger, we're no longer thinking about hunger as calorie hunger, as hunger that's met through staple grains. Much of the hunger today is micronutrient malnutrition. And addressing that would require a very different strategy than this cereal crop-centric strategy that we had in the past. It would require diversification of production systems. It would require some amount of movement away from paddy rice cultivation to vegetables, fruit, pulses, etc. And there are certain positive benefits associated with that, especially when you think about greenhouse gas emissions. That's an area that I think is worth addressing, looking at the relationship between diversification of food systems, which is needed from the diet diversification point of view and from addressing micronutrient malnutrition. And at the same time, some of the consequences, the benefits that come out of that from a resource conservation and climate point of view. It's really timely because we are all, while we're still talking about hunger, we're also talking about rising obesity levels in India. And the issue of addressing obesity would be very similar to the issue of addressing micronutrient malnutrition, because improved access to more nutritious food, cheaper access to more nutritious food would address both the micronutrient malnutrition problem as well as the rising obesity problem. While we are looking at this nexus of hunger and carbon emissions, it's also important to note that we are now in a stage where, from a science and technology point of view, we have much better opportunities for improving input use efficiency and becoming much smarter in our farming. We have opportunities for increasing efficiency in fertilizer use, efficiency in water use, power use, etc., and being much smarter about long-term sustainability of the soil resource base, and overall smarter about the way we use inputs. I think getting to a smarter food production system directly contributes to some of the climate goals that we have. And I think that's an opportunity we need to be looking at. And I'm sure it's something that Andy and Harold will bring up in their talks also. But I also see that as urban populations, as educated populations are becoming more aware of climate and environmental degradation issues, there's a greater demand for farming that's less destructive. And hence you see increased attention being given to natural farming, zero budget natural farming, organic agriculture, etc. Obviously, none of these practices are going to be universally applied across the country. But just the fact that there is interest in these areas then brings us to this feeling that there will be increased consumer demand for better food products, and that can then lead to a supply response of farmers becoming more efficient in their production systems, less destructive in their production systems, etc. And that's a consequence I think we should be looking at as we look forward. My final set of points before I open up is a lot of where we want to be in terms of this convergence of zero hunger and zero carbon depends a lot on overall government policy. And I'm really happy that Professor Ramesh Chand is with us. He is the policy expert for India, and we'd like to really hear from him. But it's really important to think about convergence of policy goals. Right now, any discussion of hunger is done through the ministries of agriculture, the ministry of food, etc. Any discussion of climate is done through the environment ministries, energy ministries, etc. But there's really no convergence of goals. There's no convergence of policies. There's no convergence of operational strategies across all these sectors. And as long as we're in these sectoral silos, it becomes very hard to create that convergence and look at opportunities for reducing the trade-offs and increasing the synergies across all of these sectors. And I think that's an area where there's a lot of work that needs to be done. I know NITI Aayog is at the heart of this convergence process, and it'll be interesting to hear about how that's going on. At the same time, in terms of policy, there's a whole set of issues around creating producer incentives to be better at farming, to be smarter at farming. The issue of current subsidies, the current focus on a few crops, etc., are issues that need to be addressed. The current procurement system in India. These are all issues that create incentives for continued behavior in a business as usual scenario, rather than switch to a smarter production system, a safer production system, etc. And finally, consumer behavior. I think consumers play a big role in influencing production systems. Consumer demand for better products, safer products, better quality products, eventually trickles down through the value chain to influencing the way food is produced, the way to make it safer, to make it more climate resilient, and less harmful from a greenhouse gas emission. So let me stop there as my opening remarks and an introduction to this webinar. We're really excited to host this webinar, and we look forward to learning a lot from it. And I'm going to introduce our very first speaker. But for all of you in the audience, if you have questions, please put your questions in the Q&A box. And then we'll be reading them out once we go through all the speakers, and then ask each of the panelists to respond to them. Okay, so it gives me great pleasure first to introduce Professor Ramesh Chand. Ramesh Chand is a good friend from several decades. I have actually watched his enormous career trajectory, going from a scientist in the Indian Agriculture Research System, a university professor in Punjab Agriculture University, Delhi University, being the director of the National Institute of Agricultural Economics and Policy, and now having that apex role as the member of NITI Aayog in charge of food and agriculture. And in that role, being the voice for food and agriculture policy in India. He's been extremely influential in policy formulation and advocacy for food and agriculture in India. Ramesh, over to you. Look forward to hearing from you.
Thank you very much, Prabhu. I really feel nostalgic when I think of early 90s when I started interacting with you. I think I will not be exaggerating if I say that in my career, I learned several things from work of Dr. Prabhu, especially when I did some work on rice wheat rotation in India. That was the time when he published a book on future of rice from Erie, and his subsequent writings really I have been, in some sense, a sort of student of Dr. Prabhu, and later on I did some work for Food and Agriculture Organization, where he was director of the program and some divisions. I did some study on food security. Again, his comments were so incisive and so insightful that since then I hardly leave any opportunity to read his work I come across and learn from that. So, Prabhu, thank you for a nice introduction. And I must say that it paid me rich dividend to stay back in the country rather than going to greener pastures. So, let me share with you some simple things related to climate change. Because we have better expert to speak on technical aspect of climate change, like Dr. Pramod Aggarwal is. I will just share with you what is our thinking and what is my thinking in the present setup of Government of India as a member of National Institution for Transforming India, which is a think tank of the government and which work for fostering cooperative federalism and competitive federalism, which mean working together, working both for the center as well as for the states. Regarding this zero hunger and zero carbon goal, we feel that this is a laudable goal and this is the ultimate which we need to achieve. But we also feel that this is something which we can achieve in the very, very long run. Like when we talk of zero carbon, we talk 2070. So if we think about short-term, medium-term kind of things, I think it is an issue of balancing the trade-offs. There are trade-offs right now, the way production is happening. There are trade-offs that if you increase productivity, if you increase, if you achieve certain growth rate in agriculture, right now it is happening with more use of fertilizer, more use of water, and more use of many other inputs, which are contributing toward increased greenhouse gas emissions. So right now, I'm not seeing that we are able to achieve these twin objectives. So we just look at it as a trade-off, and how we can balance this trade-off, and how the country which is at a stage that entering middle income category, aspiration of people, all those that issue related to food security, undernutrition, health. So how we handle this trade-off. So I wish we could afford the great luxury of achieving zero hunger and zero carbon. But right now, we look at this through this trade-off mechanism. But in many of my writing, in many of my notes, which I submit to government from time to time, and even the lecture which I delivered to sometime even to cabinet and last week to parliamentarians, I just try to convey this message to them that India now is much better positioned to pay attention to long-term goals of sustainability, climate change, than what was the position of India 20 years back. It is simply possible because our population growth rate is decelerating. Next 10-year projection is it will be only 1%, but growth rate in food production, which has accelerated slightly, and we are hopeful that in the next 10 years or so, we will be able to attain a growth rate, maintain growth rate of 3.25 to 3.5% in agriculture. So as a result of these development, per capita availability of food in India is increasing, and the gap between what is the domestic absorption or domestic demand and what is the domestic supply, that is rising. And according to my calculations, India will be required to at least export 25% of its incremental production of food in the coming years, because it will not be able to, it will not have domestic demand. So this is the situation. So in this situation, in the past, we have been sacrificing long run for the short run. I think now we can think of a trade-off where we should be sacrificing short run for the long run. We are in a position to do that. That is the situation. So when we start thinking of doing those things and talk of some real action in agriculture, so there I will begin by what Dr. Prabhu said in the beginning, that how climate change is affecting agriculture and how agriculture is affecting climate change. So this is again very important, that agriculture is unique in the sense that the relationship between climate change and agriculture is a two-way relationship. This is not same for other economic activity, industry and other things. So agriculture affect climate change and also get affected by whatever change in climate is happening. The message from that for policy purpose is that we should not be paying attention only to mitigation. We also have to pay attention to adaptation. So both these aspects, when it comes to agriculture, are equally important: adaptation and also this mitigation. The second issue which differentiate this nexus between agriculture and climate change from other kind of nexus is this, this invisibility of effect of agriculture on climate change. So we all know that a field of rice is emitting greenhouse gas 24 hours, but it is not visible. Whereas we are seeing that if there is a factory, something is coming out of chimney, so that is visible. So this I am just sharing with you that generally, if you have to sensitize stakeholders or motivate them to take any action, unless they see something or they feel something or experience something, they are not motivated. So in case of agriculture, we need to create awareness about impact of agriculture on climate change in a different way. In fact, in many situations, we are posed this question also by some knowledgeable farmers, that if this climate change, which you people are telling increased by 0.5 degree Celsius, yield is going to decline by 10% or so, why it is not happening? How come productivity of all the crop is increasing? So we really have a hard time in explaining this to them, that how R&D effort is countering it. And there are some hidden costs which are behind it, which are not seen, that real cost of production in India, real average cost of production in India is increasing. And the reason behind this is that you need to use more and more input to increase productivity by same units, which could be because that stress and climate change kind of things are already operating. So this is the second complexity which we see in case of agriculture, that making the real stakeholder realize and feel how agriculture is affecting this climate change. And third is that in many other sectors, we can find a substitute, but in case of agriculture, in case of food, it is very difficult to find a substitute. We can say that if people become vegetarian, don't consume meat, it will affect, it will be beneficial, but this is a choice of individual. It is like too much curtailing choice of individual. Giving information is one thing, but asking someone don't do it, that is his or her choice. So the inference which I draw from this situation, that since food doesn't have a substitute and the food habits do not change overnight, they take a long time to change. So rather than focusing on product, we need to focus more on practices. We can make a lot of difference to climate change if we follow different set of practice. Aggarwal ji used to produce statistics on this, that if you grow rice under submerged submergence, if you are going for transplanting, it has different amount of greenhouse gas emission than if you go for aerobic rice, direct seeded rice. So that's why I gave example that rather than seeking too much change in product, I think we need to pay more attention to practices. Then there is another aspect which is a matter of concern. Again, I raise it in several fora, including my fellow ICR scientists, that if we look at composition of growth or composition of output of total agriculture sector, the share of crop sector is declining despite growth of horticulture, and share of livestock is increasing. Again, my projection for 29-30 are that share of livestock in the total output of crop and livestock will overtake the share of crop sector, which right now is 53% or something like that, but it is going to come down to 45%, and livestock share will become 60%. And this has implication for greenhouse gases. About 80% of increase in livestock output is happening because of increase in livestock population. So you can imagine that if the increase in livestock output is happening because of increase in livestock population, and that obviously greenhouse gas emission, that means the carbon intensity in the growth of agriculture, rather than moving toward zero carbon kind of situation, we are going away from it. The way it is happening. And I don't think there are many options with us in the case of livestock right now that we can immediately increase productivity or we can change feeding practices. But this is the area where we need to pay attention. We are still having some option in case of crops. They may not be adopted by farmer, that is another reason, but we have some options. Climate smart village of Aggarwal ji and many other options we have. But in case of this livestock, I don't see many options with us, and that is making agriculture more greenhouse gas emitting sector with the increase in that share. Also on demand side, if we look at demand for food by Indian consumers, it is shifting toward butter intensive crop. It is shifting toward even butter intensive practices. People would love to have off-season vegetables, and we know that if you grow vegetable in off-season, what is its implications for climate? But modern Indian consumer, they feel they can afford it. They would like to have green peas in the peak summer month of June and July, and carrot and radish in those months. So, and the summer vegetable in winter. This is how the consumer preferences are aggravating through this effect in production. Then coming to this initiative, some of the initiative which are taken by NITI Aayog. Again, this central versus state is an issue which Dr. Prabhu understands very well. But for some of you, that it sometimes become a bit complicated or very difficult to carry something, because some decisions are with the state government and some decisions are with the federal government. But NITI Aayog has been taking several steps. from last 3 years, we have been working through the institution of Prime Minister, because our governing council chairman is Prime Minister and Chief Minister are its member. So I made two presentations that we should go for agro-climatic regional crop planning, that we should look at what are the crops suitable from nature source endowment point of view and promote those crops and minimize the crop distortions, which are quite strong at this moment. That is one initiative. Then second is initiative in terms of alternative sources of energy. NITI Aayog has been very aggressively pushing electric vehicles, even solarization. So in case of agriculture, last year budget announced, we in India call farmer Annadata, someone who is donating food. So now we came with the slogan that we will change Annadata to Urja Data. Urja is energy. So that farmers have these solar kind of replace diesel pump with the solar pumps, and surplus electricity rather than extracting extra water, they contribute to the grid and they are paid for it. So that is again the initiative which is now spreading, agroclimatic regional crop planning, this EV and solarization. And thirdly, we aggressively pushed use of ethanol. The immediate reason behind that was that we were not knowing what do we do with surplus sugarcane and sugar, because we produce nearly 30% more sugar than what is the domestic demand. So we were looking for what to do with it. Even exporting it is very difficult. International prices are lower than domestic price. If we give subsidy, we are questioned in WTO. So all those things. So ethanol, and in this budget, big announcements that petrol without ethanol will be costlier by 2 rupees per liter, that is 2.5% extra cost, compared to the petrol which is blended with ethanol. So that is another initiative which is being promoted. And coming to this convergence, as Dr. Prabhu mentioned, it is very, very important. Yes, in some cases there is divergence, but I find climate change is one area where there is a lot of divergence, in the sense that we have a national action plan for climate change. Under that, we have again 8 sustainability missions, and they are working in close coordination. We have a national mission for sustainable agriculture, where this organic farming, etc., is being promoted. But I forgot, when I was talking about initiative of NITI Aayog, to talk about one initiative. That is the initiative of natural farming. That is our vice chairman. He is very strongly committed toward it, though I have my own reservation, because I'm more worried about food security and yield penalty, and again working out that trade-off if we move from conventional farming to natural kind of farming, what kind of trade-off are involved. But our vice chairman, he is completely, I would say, in support of that, irrespective of anything. And he is the major force behind the country talking about this natural farming. I will not go into its merit or demerits, and I will not side with whether natural farming is desirable or not desirable, but just to share with you that this is something which you will find in NITI documents, especially those which are coming from our vice chairman's desk to promote natural farming. And the way he talk of natural farming, certainly it is a move toward zero carbon, but I don't know whether it will take us toward zero hunger or from present level of hunger to another level of hunger. But that is another move with NITI Aayog. And lastly, I just want to share with you that India dilly-dally for many years to ratify Conference of Party, that agreement, but in 2016, our Prime Minister courageously ratified that Paris COP Conference of Parties, and we actively played role in the Glasgow COP26. And as our Prime Minister always choose very attractive terminology to arouse feeling of people in support of something. So he has given this this agenda NDC as the name Panchamrik. So we have now those 5 action area to raise non-fossil energy to 500 gigawatt by 2030, to meet 50% of energy requirement from renewable energy by 2030, reduce total carbon emission by 1 billion ton from now onward till 2030, and India reduce carbon intensity of its economy to 45%, less than 45%, and net zero emission by 2070. And you might have heard about some other initiative like Indian Railway is targeting to make itself net zero by 2030. We are going toward electric engine, replacing diesel locomotives, all those. So that I think in railway, there is I see it as a possibility that we will be reaching near zero in railway by 2030. Energy Ministry is also working to make agriculture diesel free. So that is their target is in next 2 years, but they are working on this through solarization and other kind of means. And this is what are different initiative which I would like to share with you. And at the end, I would like to say that I hope that right set of policy and right set of innovation and participant of all stakeholders, we will be able to make agriculture as a part of the solution rather than agriculture being a part of the problem. And it is when we do this that we will be heading to achieve zero carbon and zero hunger. Thank you.
Thank you, Ramesh. That was a really great presentation. You highlighted all the major policy initiatives that NITI Aayog and the government are taking, and also the policy challenges. It's not going to be easy to get through, to get to zero carbon while getting to zero hunger. The challenges are very clear, and your presentation shows that a lot. I think one thing that strikes me is your emphasis on looking at the processes rather than trying to change the products. So getting to better farming practices, etc., is an important way forward. So thank you. And I'm sure there are lots of questions for you. We'll come back to them during the discussion session. Now let me go to our next speaker, Dr. Pramod Aggarwal. Dr. Pramod Aggarwal is the regional program leader at the Borlaug Institute for South Asia. In fact, he just moved there, and until recently was the director for Asia of CCAFS, which is the climate change project of the CJIR system. Dr. Aggarwal was also the coordinating lead author for the 4th assessment report of the IPCC for the chapter on food and agriculture. And when I think about climate change, agriculture in India, Pramod Aggarwal's name comes to the top of the list for me. He has done so much in this field and has done a lot of analytical work, modeling work, but also looks at various options for addressing that nexus between climate and agriculture. So Pramod, over to you.
Thank you, Prabhu. It's wonderful to be here, and thanks for inviting me, and thanks for such a generous introduction. I'm not too sure if I'm worthy of all that nice adjectives that you used. I am not as good a speaker as you and Ramesh. I will use support of PowerPoint, if that is okay with you. So I'll just try to make a few points. Let me see if I can share it straight away.
You should have shared screen privileges, I think.
Do you see that? Do you see my screen?
No, not yet.
Yeah, I did share already, but I don't know why it's not coming.
So something is happening there.
Is it okay now?
Yeah, perfect.
All right. So I am going to talk very briefly about this whole problem that Prabhu and Ramesh very well elucidated about climate change and agriculture, especially in Indian context. When we talk about zero hunger and zero carbon, we should expect a major advancement in the next 2 weeks. IPCC is going to release its report on this specific topic. Of course, there will be chapters dedicated to that on 28th of February. So please hold on and you will get to know the recent advances. Till that time, let me cover what we know so far. So if we're talking about zero hunger, zero carbon, we have to talk about adaptation and mitigation options. So that's exactly what I'm going to do in the next 10 minutes or so. So of course, we all know this, that Indian agriculture is very vulnerable. And we have distinction here, not only in India, the whole of South Asia, that at any given time, there will be one or other climatic risk. We talk about drought, flood, extreme rainfall, heat and cold. This large subcontinent, you will always have something happening at some part of the continent. So that's a challenge. It's nothing new. It has been happening all through. So we have been very vulnerable in terms of climatic risk. And losses because of climate risks are already very high. We know it. We see this example of potatoes, bumper production, deficit, similarly onions, cotton, practically most crops, you see this vulnerability. Now, because of climate change, as you see in the graphs here, all the red areas show decrease in production. But that's just few specific crops, but the studies today point out that production of practically everything is likely to be affected. Talk about crops, milk, eggs, fish, meat, everything is likely to become less, but even more critical is more variable. So you don't know what exactly you will be producing next year because climate is becoming more and more variable, more extremes. So that's the real difficult situation. But the good thing is, which becomes sort of good in this context, that we have still large yield gaps. India, by and large, in most crops, except let's say to some extent rice and wheat, but practically all other crops have large yield gaps. There's still that's tremendous potential that needs to be tapped. And adaptation can certainly help there. So that's, I think, is the silver lining, that yield gaps can help us in producing more food. Just to illustrate that, this is an example not only from India, but from all over the world. This is data published in last 30 years about climate change impacts on rice, wheat, and maize. It's a synthesis of all studies, as I said, published so far. This is, well, let's say 3 years ago. Wheat, 2050, 2050, wheat, rice, and maize. What is likely to happen? So all those yellow bands that you see are impacts of climate change. So practically all crops, as you can expect, are likely to go down from 5% to 25% by 2050. That's the average scenario at mid latitudes where we are. But look at the blue bars here. These are adaptation. In case we follow adaptation strategies, very simple agronomic adaptation strategies, a large part of this negative drops can be managed. We can bounce back, of course, not necessarily perfectly with the current technology, but still we can minimize the impacts of climate change by adaptation strategy. And as I said, this is based on global studies. In wheat, practically, we can nullify much of the impacts of climate change, but in maize and rice, to a large extent, we still will not be able to cover the whole impacts. But what is important for us not to be driven too much by this type of maps and analysis that you see, because these are only long-term scenarios. What we really need is action today. And to do that action today, we really need to link what should be adaptation with our current risk profile. And it's not very difficult to characterize it. What you really need to understand, what is the frequency of loss, what is the intensity of loss, typical analysis that is done for insurance purpose. And then you can classify your regions into high risk, medium risk, low risk, or very low risk. I think that first characterization is very important. How much is the risk? And we just don't talk about climatic risk, we talk about integrated or holistic risk here. This is illustrated here for Maharashtra, one of the important states of India, for cotton and soybean. So in soybean, for example, you see some red spots. That means there's a very high risk of growing soybean here. Yet farmers grow because of market situation and because of other constraints that they have. But overall, soybean has either high risk or medium risk. Whereas cotton, of course, very popular crop, but still lots of green areas, which are very low risk. And the dots that you see is how much crop is being grown there. So if you do this type of analysis, you really understand how to target your technology, what adaptation strategy should work. And that's what you see here. I don't want you to read it. It's too complex right now. But you can split your strategy based on the risk profile. For example, here in case of Maharashtra, we say high risk area is only 2%. Very limited area, only 2% area. But large area, almost 50% area is in medium risk category in Maharashtra. And low and very low is about 21%. But for each of these, you need different strategy. You need yield growth because we still need to produce more. You need adaptation or risk reduction strategies. You can also use risk transfer strategies like insurance. And of course, there are always some GHG mitigation. So in high risk areas, we don't believe that we should be targeting too much about yield growth. It will not really show any results. But what is necessary here, diversify to more non-agri option. The limited area, think about moving out of agriculture, where it's very high risk for agriculture. Insurance, we should not really be thinking too much, rather focus on social safety nets and don't think too much about GHG mitigation, too risky to produce crops. So then you go on, and in a medium risk, there are different types of strategies, limited for yield growth, but a lot of scope for adaptation. Again, here, risk transfer may not really work very well because insurance premiums would be fairly high. Rather focus on developing innovative social safety nets. Not too sure if GHG reduction would really be of much use here. Similarly, go for low risk and very low risk. In very low risk, I think one has to really focus on yield growth strategies. That's the most important. How do we produce more in such areas which can take care of risk and yield penalties in other areas? So like this, you can really work out what technology, what adaptation strategies, what mitigation strategy, what risk transfer strategies one should be using, rather than making very blanket recommendation that all over we should do that. So I think that type of analysis is quite important for us to undertake. We did this very recent work. Also, you see participatory prioritization. Lots of stakeholders, we took their view that these are some of the top strategies that they think can really help Maharashtra state in building resilience over time. Again, I will not go through this whole list spanning from crops to livestock to agroforestry. But the important point is that there's a lot of scope for adoption. Still, the maximum adoption that you see for any particular technology is at best 50%. And there's a lot of scope for all of these technologies. And that's what gives us confidence that we should be able to take care of lots of the challenges that climate change is posing to us, provided we are able to scale them up. Another important point that we often overlook is maladaptation. It's something we have to learn lessons of our past mistakes. Today, we often blame Green Revolution for lots of negativity as well. Now, same way, if you talk about current adaptation strategies, we have to make sure that they don't become maladaptive tomorrow. Otherwise, again, after some time, public at large will be blaming us for encouraging something that is not really adaptive in the long run. So we did some very simple analysis that what you see here, this is on x-axis today's income and y-axis what happens when change strategy. There's simply intensification. It says each dot represents a farmer here. These are about 1,000 farmers of a typical climate smart village in Maharashtra. So what you see at a given time, there are lots of situations where there are yield penalties. Not every time intensification is going to work. So again, we're very used to making blanket recommendations, but those blanket recommendations you see here don't necessarily always work. And what is very important for us to see, even very simple thing like intensification, more inputs that we often talk about. When you talk in future climate, you see lots of these data shifts towards lower side of one-to-one line. That means what is today working very well need not necessarily be working very well in tomorrow's climate of high temperature and poor rainfall. And if you talk about climate smart agriculture strategy, again, you see here, it can really help to a large extent in today's climate. But what happens in future climate, again, you see a lot of these strategies will shift, will become rather penalty. So one has to really understand what works and what doesn't work, not only in today, in what context it works and what context doesn't work, and whether it will remain an adaptation strategy in future. I think that's an important point, which is often again overlooked. Let me quickly move on now to this emission scenarios. Just, I'm sure most of you know, but just to summarize, India's GHG emissions about 2.5 million gigagram total, and only 14% of that is from agriculture, directly from agriculture system. Of course, we're not talking about the whole value chain here. 74% comes from energy, lots of electricity, other gasoline resources, etc. That's what is the major emitter. And within agriculture, it's 8% is enteric fermentation from livestock that other speakers are going to talk about. Paddy is just 3%, soils are 3%, and others are relatively negligible. So major sources are livestock, paddy, and soils, fertilizers, etc. that we use here. So that's the maximum that you can be thinking about from agriculture. Emission intensity in agriculture has been decreasing with time and decreasing very significantly, simply because emissions are static for quite some time from agriculture, and our production is increasing continuously. A growth rate of more than 1 to 2% that I think Ramesh already alluded to. What is also very important for our friends from outside to understand that we have very advanced laboratories in India for GHG measurement. State-of-art facility, we have lots of flux towers measuring continuously what sort of emissions are taking place from all types of cropping systems in different agroecologies. We have that. And for these inventories, we are using tier 2 emission coefficients. So the point that I'm trying to raise, these inventories are fairly solid, very robust, based on very solid coefficients measured locally. When we talk about zero hunger, I'm sure we are talking in terms of Indian context. Most of us know what exactly is Indian diet. Indian diet is relatively simple, to a large extent vegetarian, as you see here. And when it comes to adding some more protein, we add milk in general. Most people take milk. And some of my friends also will take chicken. Very little mutton, by and large here. Now, a very recent study, very interesting study, I'm sure most of you have seen. It's just come very recently, where they compared emissions from a food recommendation that different countries are making. Ideal dietary recommendations that different countries have made, comparison of few selected countries. This is the ideal one. So what you see, India is the lowest. In terms of food, we are emitting the lowest in the world. This is a comparison of some US, European countries, Middle East. Of course, there is no African country here, and also Southeast Asia. So you see, our emissions are lowest, 0.86 kilogram. That's all we are emitting. It's as against US, which is the largest in terms of food, is about 3.3. Even the EAT Lancet, again, a very popular document, which is getting more and more traction in recent time. The recommendation that they have for ideal diet leads to 1.4 kilogram emission compared to India's 0.86. So you see, we are already fairly low. So one has to really think how much more we really want to reduce. Because producing food will obviously mean some emission. It cannot be, that you just don't produce any emission. There will be some emission. It's a necessary byproduct of producing food. Well, we can claim, yeah, zero, but it may not really happen. Of course, you can reduce it. But should we really be prioritizing when ours is already very low in terms of emissions from food? Just to give you a little bit more insight into this, this is based on recommendation. Our current emissions are 407 gigagrams. If we all follow a healthy diet, that's what we are all talking about, zero hunger. Zero hunger also means zero malnutrition. By ICMR standards, Indian gold standard, we should be, if we follow that, the amount of protein that we should be taking, amount of milk, amount of cereals, fruits, vegetables, for a perfect diet, we will be emitting 1186. That is almost 3 times more than what we are emitting today. And if you follow Eat Lancet diet, which globally everybody talks about, it will be 4.6 times. If all Indians start taking a well-nourished, and that's what we all want. So point is that when we talk about zero hunger, zero malnutrition, we should be aware that for such a large population that we are talking about, there's no way but emissions will happen. How much of this we can reduce is something that one has to see. I would also further like to provoke you in thinking a little bit more about this zero carbon and zero hunger. Now, as I already alluded, we have low footprints in terms of carbon from agriculture and diet, one of the lowest in the world. It would increase, again, as I showed, because we are targeting more nutrition, more zero hunger. But we have to also see picture in totality. Bottom graph once again shows that agriculture is only 14%. Is this the best option for zero carbon? Or should we really be exploring opportunities where we have more scope, 74% energy sector? Within agriculture, 8% livestock. We know what sort of constraints, social constraints, political constraints we have in terms of addressing livestock issues, in terms of GHG reduction. Easier said than done. Paddy only 3% and soils only 3%. Look at this paddy, and I'm sure speakers following me will already address many of these and will contest this. But how much of mitigation is really possible in paddies? Now, this is percentage distribution of different water types. Now, the main source of mitigation rice is alternate wetting and drying. That's what everybody talks about. But where is it possible? It's already happening in much of our current system. You see, drought prone, there will be aeration. Flood prone, very difficult to do anything. Upland, again aerated. Multiple aeration, single aeration, they're all already aerated. The only scope that you have is in continuous flooding, which is 16%. And there too, now it's not always easy. It's only in some irrigated areas where you can possibly implement alternate wetting and drying. Rest of the places already happening. I don't mean to say it's not possible. It is possible. There are lots of practices that we should be thinking about. But overall, in terms of national context, when you talk about zero carbon, how much you can reduce? You will reduce 1%, but then you have to think about at what cost. 2% at what cost? Social cost, political cost, technical cost. I think we have to see all costs in terms of addressing this issue of zero carbon. Instead, if we target what I think Ramesh already alluded very well to this, about solar energy. India is totally sold these days to solar energy. And this is a very interesting community program which we had together with the International Water Management Institute. A community solar irrigation system. It's a win-win for farmers, more production, more income, GHG mitigation, very environment friendly, and cash from surplus energy source. The system is already working at several places in Gujarat right now. Please come and see this for yourself. fairly successful by all means, social, economic, political, it seems to be working. Of course, once it is scaled up further, we'll know what sort of other opportunities exist. But possibly this type of system will provide much more mitigation, much more support, producing more food, rather than thinking about only very small fractions, possibly, which you can get from paddies and livestock. Let me summarize and let me give you some final thoughts. We believe that we have lots of technologies today. We really don't need to invent many more because we have not really capitalized, as I showed earlier, plenty of technologies, known technologies, which are technically feasible for increasing adaptation and also mitigation. But most of the time, we have not really seen things in totality. We keep talking about technical feasibility, but whether they are socially acceptable and economically viable is not necessarily always understood very well. So I think that's something that we need to do. A point, as I said, provocative point that I want to leave with you for further discussion. Agriculture emissions are relatively low. 14% is relatively low. And within that, if you look at sectors, it's not really easy. And we should really be saying a bigger picture in line with NDC. NDC, if you know, Indian NDC doesn't have any sector-specific mitigation targets. There's no specific target for mitigation in agriculture per se. It's a target, overall target of reducing emission intensity from India, not necessarily from agriculture. So if you can attain the reduced emission intensity from other sectors like solar, etc., should we really be focusing so much energy on mitigation in agriculture, where it's going to be a Herculean task? We can demonstrate, we all have demonstrated, we have also demonstrated in small plots, in farmers' field. Yes, we will be able to reduce emissions by 20%, 30%, 50%, but think of scaling up in this country to get that 1%, 2% level. I think that's a challenge. What is also very important for us to realize that most adaptation options will anyway have co-benefits. There will be mitigation. Most adaptation options, what are these? These are all related to efficiency. Efficiency of water use, efficiency of fertilizer use, efficiency of land use. Those are adaptation options, and they will always have mitigation co-benefits. Important point, again overlooked, adaptation also, one has to see what is likely future of these adaptation strategies. But we are not talking of today, we're talking of tomorrow as well. And final points, what is really needed is a holistic story. What we need is scalable, not just pilots. We've done enough number of pilots, also together with Girish ji here. Lots of pilots we've done, but how do we scale them up? So what we really need is integrated, really integrated, region-specific solutions, bundling lots of these technologies together, bundling with insurance, bundling with mitigation strategies, linking to climatic risk, linking to finance available and finance needed, and what sort of incentives are needed. That's a tall order. I hope research will be able to guide us better in this. I will leave this because I think I was asked to talk about GHG coefficients. I have tried not to talk about it. I come from labs where all of these measurements are done, and I'm continuously fighting with my colleagues who are trying to update these coefficients every day. I think the returns of investment, research investment in improving coefficients is less compared to what I have listed above. Thank you very much.
And thank you, Pramod. Thank you for really comprehensive presentation showing the India story. I think you've succeeded in being provocative. So we should, I'm sure, get a lot of questions on that. I was particularly struck by this trade-off between a healthy diet and increased emissions, something that I'm sure others will pick up on and bring into the discussion. Thank you. Our next two speakers are from Cornell University, and I'm going to introduce them together. Ms. Harold Van Ness, who is a professor of crop and soil science in the School of Integrated Plant Sciences, Harold is the former president of the Soil Science Society of America. He is also the former head of the Soil and Crop Sciences Department. Harold has done a lot of work on nitrogen use efficiency, smarter use of nitrogen, soil health, metrics, etc. He won a major $1 million international award for his work on adaptive nitrogen technologies. So very impressive work from Harold. Andrew McDonald is also a professor in Crop and Soil Science Department. Andrew is a cropping systems agronomist and ecologist. He spent several years living in South Asia and working on crop intensification of the rice wheat system and sustainable intensification in South Asia. He knows Bihar more than most Indians know Bihar, and spent a lot of time in the region. So both Harold and Andrew bring a lot of expertise to this area. Over to you, Harold. I think you're starting off.
Great. Thank you, Prabhu, for that introduction. And good morning, good evening to everyone. So when we think about crop systems and the discussions that Andy and I have had over the past few weeks, it's interesting in terms of identifying strategies and sort of taking that first step, but also, you know, being very considerate of misinformed strategies. You know, questions that you raise, you know, what do we know well? What do we know not so well? What don't we know? What don't we know that we don't know? And there's a lot of that because there's complexity and diversity in the system, and the right decisions are sometimes a little bit hidden. So we have a complex system, obviously. You know, compared to other economic sectors, agriculture deals with more than carbon dioxide. You know, most of the other concerns are related with fossil fuels. Agriculture, of course, has methane and nitrous oxide as well as major contributors. And agriculture is unusually complex, of course, especially in the Indian production environment. So we're having these different greenhouse gases. They exchange with the atmosphere, and we have the biomass, and we have the soil system. And there's fluxes up and down. Most of the biomass, of course, gathers carbon dioxide through photosynthesis. Some plants do more of that than others, like maize does it more than, say, wheat or rice. Perennial systems tend to be very beneficial. We have livestock in the system, and Mario will address that. All of those systems can contribute to soil carbon, but can also have a negative impact on soil carbon, which is what has happened over the past centuries. Rice is particularly complex, of course, because it's not only the carbon, the methane, and the nitrous oxide. And with rice, there's this real risk of trying to reduce one set of emissions, say by reducing flooding, where you potentially could increase the emissions of another greenhouse gas like nitrous oxide. And then last but not least, we have a lot of lateral flow. Even though we have sort of vertical flow into the atmosphere and the biomass in the soil, we often have quite a bit of lateral flow, harvested products that may either go to livestock or for human consumption, and that's non-circular. And then when we look at the complexity of the system, it can be somewhat overwhelming. This is a schema that shows the complexity around agricultural burning of crop residues, where we have so many operational and socioeconomic considerations around the production system, the labor, the equipment, the livestock, et cetera. So the question then becomes, well, where are the trade-offs and the leverage points? Now, the good news is that according to McKinsey, the so-called usual suspects of methane from rice, nitrous oxide from fertilizer, no-till, and carbon and energy use, that if they are addressed, then we can actually make a lot of progress. And the vast majority, about 4/5 of the technical mitigation potential is actually cost beneficial. So that these are basically win-win opportunities, and you see that in this graph. That some practices like zero-till or more efficient nitrogen fertilizer use benefit the farmer, the environment, and also enhances food production. So there are a lot of win-win opportunities, but they're not currently taking place at scale. So this is something that needs to be addressed. And the identified pathways are probably inadequate to meet the scale of the climate crisis. At least that's what Andy and I surmise at this point in time. So what are some of the motivating questions? Are existing emission estimates sound? I mean, we have a lot of data, but do we have the level of comparisons of data? For example, dealing with methane and rice, could we perhaps make the problem worse if we increase the carbon content of those soils, or if we change the flooding frequency? Does it create more nitrous oxide versus methane losses? So we need to be better informed on that. Which opportunities for mitigation most strongly align with the zero hunger and the food security idea, and what are the main barriers, and how can we accelerate transitions and prioritize? So just to give you some examples, of course, this is a vast and diverse sort of universe here around food production in India and Bihar especially. But one sort of very simple example is that rice transplanting date impacts yield and impact fossil fuel use. So if you basically end up doing the transplanting too late, you're seeing a loss of yield, which means less biomass, less carbon captured out of the atmosphere. But it also then tends to result in higher irrigation demand. So that means that, since most of these irrigation pumps are still diesel powered, that means that there's a fossil fuel component of that. So here's a very simple and straightforward way to better management to address both the food security and the climate issues. And here's an example from wheat. This is some work that Andy did, looking at the regression trees. The most important factor is planting date, and secondarily irrigation, and thirdly is nitrogen fertilizer. So these are practices that we know can enhance production and can reduce environmental impacts, and these are known, and they can have a major impact. Soils, of course, are a very critical component of that. Much of the area that we're considering here has a considerable sort of carbon gap. That means basically that there's considerable opportunities to increase soil carbon content and thereby the health of the soil. And this has a self-reinforcing effect. That is, if we improve the crop production, higher biomass, and better carbon cycling, we then improve the health of the soil and the carbon storage, and have more and greater input efficiencies. That in turn increases the productivity and reduces greenhouse gases. So soils are a big part of the solution. There's a number of other practices that we can consider, and I think most of you are very aware of that. Of course, the residue burning is a big issue. A lot of carbon ends up in the atmosphere and not in the soil because of that. Minimizing physical disturbance by using zero-till practices, we know that that's beneficial. And of course, closing the carbon loops when we consider livestock in a more diverse cropping system. I want to show some data from my PhD student, Kavya Krishnan. She did a sort of comprehensive analysis of a number of field experiments with different crop management systems. And I'm just showing the organic carbon data. She did a much more comprehensive soil health assessment. But basically what this shows is biomass and tillage matter. If you have a fallow in your system, so that means you have less biomass being produced and taken out of the atmosphere, that also means less biomass and carbon goes into the soil. And we see that here, that the rice, wheat, and fallow system has lower carbon levels than where there's a third crop. We see that tillage matters, that the lowest organic carbon levels were associated with the most intensely tilled systems, And even if one component of the rotation is zero-tilled, we see a benefit. And we see, of course, benefits from crop residue and manure applications as well. And even we see a fairly nice relationship between crop residue levels and organic carbon. And this is work that was done in collaboration with BISA and CISA and Rajendra Prasad Agricultural University. So we know that these management practices can be beneficial. We also know that nitrogen is a very important component, and we know that the N balance is a very useful metric to look at the nitrogen use efficiency, N balance being N input minus N output. And what we've learned, not only our work, but others as well, is that the relationship between N balance and generally N fertilizer rate and environmental losses is nonlinear. And some of the more simplistic calculators like the IPCC Tier 1 assume that it's linear and that it's relatively small. But as it turns out, if you can reduce the excess nitrogen in a system, you have disproportionate benefits. And so this map here from some of Andy's recent work shows areas that are hotspots for excess nitrogen application, where it is known that if you reduce the nitrogen rate, you basically still end up getting the same yield, but with higher nitrogen use efficiency. So there's a spatial dimension to this as well. But there's lots of opportunities with nitrogen, especially in environments where the fertilizer use is heavily subsidized. And then, of course, we have the complexities around the rice systems. And so the methanes, nitrous oxide, the carbon dioxide, all kind of come together in this system. Diversification should be perhaps on the table, more efficient management practices as well. One interesting thing there is, and this is again some of Andy's recent work and with EDF, is that there's a lot of diversity in terms of how these systems are being managed. And the green line here shows the flooding water table, or the depth of the flood water table from two fields which are nearby in the same region. And in one case, there's a lot of intermittent flooding, while in the other case, there's a lot of continuous flooding. And so there's just a tremendous diversity of production environments that we need to be aware of. So with that, I'll hand it over to Andy.
Thanks a lot, Harold. Tough act to follow. All the speakers today have been great, and thanks everyone today for joining. I'm just going to offer a few short comments to keep us on time, and we're going to frame these in terms of preconditions. And this first precondition for a zero hunger, zero carbon future really comes down to the point that Harold made in the last couple of slides about understanding cropping landscapes. And I'll draw your attention to some of the survey work that the KVK system that is led by ICAR has done with CISA to really fill in the gaps of our knowledge of landscapes for production practices, yield outcomes, including work on predictive mapping for soil properties and things like that. With that kind of characterization, we can do a much better job of both understanding where greenhouse gases are coming from, inform priorities, and power new approaches to devising and communicating scalable solutions. So this has been a priority now in India through the ICAR KVK collaboration, and it should expand. And we can do a lot more if we have better data at scale. Next slide, Harold. The second precondition that we wanted to mention is that there are a lot of orthodoxies that still have a very heavy hand in the way that we talk about the opportunities around mitigation, adaptation, and intensification. And so that first panel on the left is our provocation to say some of the things that we talk about in terms of intensification and things like N2O emissions simply don't hold up when you have those better data assets to inform your understanding of how cropping systems function across farm diversity. So what we're showing there actually is the yield level for rice. This is in the Eastern EGP. in the eastern Ganges Plain, and rice nitrous oxide emissions. And what you can see is actually the higher yielding farmers, we estimate, are producing much less nitrous oxide, not just yield scale, but absolute emissions. So again, the better data that we have, the more that we can unpack the story and to know which production systems and which farms need to be targeted to drive down emissions without compromising food security. The second thing that I want to mention on that goes to the right. Prabhu and Dr. Aggarwal had talked quite a lot about precision farming and the role that can play. We know that a lot of things are technically feasible, but we still have this gap of bridging between what we can do with sensors and other sorts of field level precision management strategies, and how to extend those to smallholder systems. With these better data, we can do a lot of work on landscape segmentation with things like machine learning to guide where we go and what we do, and to bridge this gap between technical feasibility and the promise of precision solutions and actually what reaches farmer fields. Next slide, Harold. The third precondition that we wanted to talk about, and this has been mentioned by other speakers, but this real need to move beyond technical feasibility and social desirability. We know that that's simply not good enough, that we have a lot of things in the toolkit that have languished in the toolkit because we haven't approached change processes comprehensively. I won't go into too much detail on this, but this is work that R.K. Malik and others have done for quite a long time in the eastern sector in India, but thinking about zero tillage. We talked about the value of zero tillage in terms of yield gain, in terms of cost reduction, in terms of energy reduction for probably 25 years. But the key to all this, to get this technology to move, hinged on awareness and evoking social networks, but also thinking about what messages motivate farmers to change behavior and having service providers in place so that the barrier of the capital intensive nature of the technology is overcome through business creation. So by focusing on that component of the system, Dr. Malik and his team through the CISA project were able to get the technology to move. And these numbers are a little bit out of date, but since 2012, there's an emergence of more than 4,500 service providers in Bihar and Eastern UP now, and upwards of 100,000 hectares that didn't exist before. Next slide, Harold. And the last thing that we wanted to note in terms of preconditions is that we need to be considering multiple impact pathways, that there's no one solution. All these things have spatial dimensions, and we really, I think, need to take a step back. There's, of course, there's a diversity of things to consider, and Harold's mentioned most of them, but on systems intensification, soil and water management, carbon circularity, precision technologies, and energy and agriculture. But within this, understanding processes, understanding landscape and social system variation, and setting priorities accordingly so we can push through to get traction and adoption of promising approaches. Next slide, Harold. And so our final slide, looking ahead, this ambition for these emerging partnerships around zero hunger, zero carbon. There is a need to increase understanding and management of mitigation trade-offs. Harold mentioned these things before, but in terms of SOC and methane production, also work that Kriti and others from EDF have done on methane and N2O emissions, and of course, similar analogs with carbon and N2O emissions. To understand these, it's not just about having better models and better emission coefficients that apply to research plots, but again, going back to that concept of having better characterization data at the landscape scale, including things like drainage that are not well mapped. So there's progress to be made. The second point to reemphasize is that we need priority setting that honors the net mitigation potential without compromising food security, profitability, which is the main motivator for farmers. And of course, things are changing in this space with voluntary carbon markets. But lastly, that putting in this component of the scaling potential of innovation, so that we are not up against the wall promoting things that really are not resonating with farmers. And putting all that in a spatial context hopefully will help facilitate transitions. Within that, No one organization is going to be able to support change. We need progressive policy and leadership, and then we need creative partnerships within that build these approaches around comprehensive theories of change and better tools. And hopefully, if we do that together, we'll be able to mobilize and coordinate partnerships to really evoke and achieve the sustainability transitions that we know that we really, really need. With that, I'll end. Thank you very much.
Thank you. Thank you, Harold and Andy. Great presentations and really highlighting the advances in science and technologies for dealing with the complexity of zero hunger, zero carbon. Thank you so much. Our next speaker is also a professor from Cornell University, Professor Mario Herrero. Mario is if I have to say in one sentence, I would say a global expert on food systems and climate, and particularly knowledgeable on livestock systems and the intersection between livestock systems and climate. Mario, over to you.
Thank you very much, Prabhu. It's a pleasure to be here with all of you. Thank you very much. I'm going to talk about adaptation and mitigation options in the livestock sector. Let me share my screen. And how many? And for me, the key here is that well, you know, there's a lot of things occurring at the moment in the space of environmental management and trying to increase the sustainability of food systems. And the livestock sector plays an absolutely critical role in many of these. The demand for livestock products has been increasing dramatically in the last 40, 50 years. But in the last 25 years or so, what we see is three stories of per capita demand. Pork and poultry growing at accelerated rates, in many countries growing at rates of around 8% per year, which is absolutely incredible. Dairy also growing very rapidly in low and middle income countries, but stagnating in the OECD. And contrary to what many people believe, red meats are stagnating basically everywhere. We're even seeing reductions in the consumption of red meats all around the world. Having said that, when you compound this with the population increases around the world, what you end up observing is a graph like this, where you see the total demand of livestock-derived foods around the world. And I want to single here South Asia, where you see this brown line going up here.
Mario, your slides are not changing.
My slides are not changing. Okay.
We have to put it in slideshow.
Okay. Are they changing now?
No, not yet. Am I the only one having this problem? Or?
No, for me also, they are not changing.
You should, if you go into slideshow mode, maybe.
I think you may be sharing the wrong screen, Mario. That would be my guess.
Okay, let me then check again. No problems. Okay, do they change?
Let's try now. Yeah, that's.
Oh, okay, great. Sorry. So yes, so the picture that you see is then becomes something like this, and of course, let's not have a look at the dramatic red line of East Asia and the Pacific, which is really where the majority of the livestock product consumption growth is expected. But let's focus here on South Asia, which, although the line might look relatively modest in terms of increases, we are actually talking about likely a doubling of livestock product consumption. Now, obviously, when you see numbers like these, the first thing that you wonder is, well, from where? How are we going to produce all these additional livestock products? Where is the land going to come from? Where's the feed? What's going to happen to water? What's going to happen to emissions, etc.? And that's actually the main concern around the growth of the livestock sector. It's really how can we accommodate this growth within the current boundaries that exist in countries in the world, etc. So it's not a trivial matter. It's very, very significant, and it will not go away easily, because we know that behaviorally people eat as people get richer, people consume more livestock products, and also when they get more urbanized. And you know, it's in the places where we see these large increases in income growth where we see the biggest increases, like in places like India and so on. But at the same time, you know, it's compounded by enormous difficulties, because we also have multiple and varied climate change impacts. In many cases, we are actually talking about that this is not only about droughts or floods, it's really all sorts of things. It's really about droughts, floods, climate variability, it's heat stress on animals, etc. And with a very, very different sets of impacts in different parts of specific countries. Just to give you an idea, in a recent paper by my colleague Philip Thornton, we estimated that livestock losses of heat stress only would be of around $40 billion per year. And this is just the productivity losses that you get from the heat stress of the animals. Now imagine all the other compounded losses that you get. So when we talk about options for farmers, and then on top of that, we get the double burden, which is the greenhouse gas emissions that the world wants to mitigate. And I want just to show you here some of the hotspots. And as you can see, well, India, due to its large numbers of animals that don't produce a lot, but animals also that don't emit per se too much per animal, but where we have really millions and millions of animals contributing to a significant hotspot of greenhouse gas emissions. So trying to achieve both the adaptation and the mitigation at the same time will require very smart practices that we can actually implement that can actually help us deal with both aspects at the same time. And there's a big compendium here on the kinds of things that one could do. And this comes from the special report on climate change and land, where we actually see that there's many options around both livestock and crops, where we could actually get joint benefits on mitigation and adaptation. This is crucially important, because probably what I'm saying here is that, as Andy and Harold said, we need to treat this as production systems, all in all, where one specific practice will have many repercussions on different components of the farming system. And that should be seen as a real positive rather than as an issue. Look, for example, here some of the ones that you could do with livestock: the feed and the fodder banks, seasonal feed supplementation, improved management, some early warning systems, new livestock breeds. All of these can actually contribute to both help mitigate and adapt systems. And in India, there is some very good examples of these things occurring already. Now, let's move towards the greenhouse gas emissions. There's been a lot said about the percentages contributed by livestock and so on. We know very well that, look, whether it is 14% or 10, it's a very, very significant proportion of greenhouse gases coming from the livestock sector. We know that 65 to 78 come from large ruminants, especially cattle and buffalo. We know that enteric methane is the most important source, together with land use change, basically from feed production. Those two account for the majority of the emissions from livestock. And we also know that about 60% of them come from mixed crop livestock systems, like the ones that exist in India. We also know that there is a very broad range of mitigation practices, many of which share the adaptation opportunities. But of these, probably the simplest to implement in farms is actually improvements in the diet of the animals. Improvements in the diet of the animals through green fodders, through improved crops with improved crop residues, supplementation, etc., and animal husbandry as well. Probably more difficult and of limited scope is soil carbon sequestration, and especially in grazing situations where we have not been able to get good improvements in soil carbon, especially in the permanence of the carbon. We've seen increases that are momentary, but with climate variability, these are wiped out in many places, especially in arid lands. So here, the technical mitigation potentials, as I said, carbon sequestration with some potential, but the red portion of the graph is actually the variability that you would get, with the improved feed digestibility being probably the practice that has the greatest potential here. Feed additives in some of the systems will be really important, especially as yields increase significantly. The avoided land use, animal management, rangelands, and a range of others. As Harold showed here, it is not surprising that some of these options are also the most cost-effective for India. If you look at this portion of this marginal abatement cost curve by Tech-Sapkota, green fodder supplementation, improved diet management for ruminants, molasses, and increased concentrate feeding, these are in a portion that is relatively cheap to implement, and that could have some important mitigation potentials here. Now, how does this work? This is a very, very simple example with data of a project that we did for the Bill and Melinda Gates Foundation, where we are actually, here in this graph, we have the milk production of the cow in the x-axis. And you can see it goes from 0 all the way to 8,000 for the super highly producing cows. And this is the methane per kilogram of milk produced. So what we can see is that as the cow increases the milk production, the methane per kilogram of milk decreases very, very significant. And the milk production basically increases through better feeding and better management and so on. So if you take the baselines, basically the average of a particular country or region, and compare it to what the best farmers in that particular situation are obtaining with local feed systems, we know that this vast improvements in the order of reductions of 300% can actually be achievable under the conditions of what the best farmers are implementing. They are the ones really implementing all these supplementation practices and so on. So the key here is to really try to move towards implementing these systems at scale in ways that actually really support perhaps moving towards less numbers of animals, simply trying to have more productive but less numbers of animals, so that we also make a land use saving, which is actually critical in all of this. It's not only about the methane. It's not only about the methane. It's really about how we're going to use land, because there will be a very significant competition between feed and food crops and so on. And that's precisely why we really need a systems analysis in all of this. Again, this is with a project that we used to have in Odisha with the Bill and Melinda Gates Foundation, where we tested several scenarios of what was feasible through improved feeding and crossbreeding. And here you can see that from the baseline, you can actually have significant increases once you start upscaling at the state level some of the practices. And here you can observe what would happen in terms of the availability of milk per capita that could actually improve nutrition for humans. Certainly, between increased feeding and replacing some of the indigenous animals with probably crossbreds or with buffalo, we would actually obtain significant gains in the production at the state level. So these are the kinds of things that we need to be trying in this type of systems. But I want to make a caveat here, because it's not always rosy when you really try to implement mitigation practices in these systems. I think that still the focus on adaptation is extremely important, and with mitigation as a co-benefit. In the most recent studies, and this is something that we presented in the IPCC special report on climate change and land, is that sometimes if we try to implement mitigation too hard in many of these systems, especially when we go for land-based mitigation, trying to take land out of production, this mitigation impacts on food prices become very, very bigger even than the prices of the climate change per se, on the impacts on crop losses and so on. So this is something, and in animal source foods, the same actually happens. If you look at the price increases, they're higher when we try to mitigate and try to take land out of production, because we create a very important scarcity of the product that ends up changing the supply and demand curve. And what we've done, this is a very important paper from Hasegawa in Nature Climate Change, who tracked down how these commodity prices will therefore increase the population at risk of hunger. And if you look at the case of India, in this particular case, in many cases, you get bigger effects from trying to go very hard on mitigation than if you just accepted the climate change impact. So in this case, probably adaptation with having mitigation as a secondary objective might fit better in some of these systems, especially where you have a lot of vulnerable people. But as I said, plenty of options. It's just about smart strategies, designing appropriate packages, and trying to implement this at scale. Thank you very much.
Thank you, Mario. Great presentation. Dealing with livestock issues and climate change is really complex, especially in really smallholder livestock systems. Yeah. And I think some of the data you provided is great. Thank you so much. I know you have to run, so thanks, and see you again.
Yes. Bye-bye.
Next, I have Girish Sohani, who is the former president of BISA Research Foundation, Research and Development Foundation. In my view, BIF is probably one of the leading NGOs in India that works on on smallholder agriculture systems across the country. And BIF has a particular expertise in livestock and livestock production systems. So it's nice to follow Mario here. I think one of the things that I like a lot about Girish on his work is that he's very much rooted to the ground. His feet are always on the ground, and he knows, he has the pulse of smallholder farmers across the country. So it's great to have him on the panel. And I've given him an impossible task of synthesizing across all of the presentations that were made. Girish, over to you.
Thank you, Prabhu. Thank you so much. And let me also thank for inviting me for this very interesting panel discussion on a very important topic. And it has been really a great pleasure to listen to all the speakers, their words of wisdom out of the deep experience they have in their work. And I think bringing out, in a way, the enormity and the complexity of the task when we are looking at climate change impacts, and how through this muddle we have to move towards zero hunger and zero carbon as simultaneous goals. So I think this is something which is a very important topic, and we have had very interesting points made, which, as you said rightly, it is so difficult to synthesize. But I would like to touch upon some of the key elements that came up through the different presentations. First thing, Prabhu, what you said initially very important was looking at the past history and experience we have of the Green Revolution impacts and what it has led to, whether it was not as a matter of critique, but as a matter of learning, and where do we go from here in terms of achieving the zero carbon goal. But at the same time, the Green Revolution did address the matter of hunger. And now from that, we move to also addressing hunger, not as just quantity, but also quality. So not just protein and calorie, but also the diversity and the micronutrients that are required. So I think we have a challenging task looking back from where we come. And probably convergence of goals and policies across sectors is what will need to be addressed, as you very rightly pointed out. And we had a very interesting top view perspective from Professor Ramesh Chand, the very national policy perspective, where he talked in a very realistic manner about not just the long-term goal, but also looking at what are the trade-offs in the short term that one may have to address. And he also very appropriately pointed out, looked at what the changes that we see in terms of the trends in agriculture, the reduction in the percentage share of crops as against the increasing percentage share of livestock products. And that is the trend that is also going to be projected into the future. So that is something which we have to understand when we are talking of the agriculture impacts on climate or the climate impacts on agriculture. We have to keep this in mind. And therefore, he also pointed out very well that it is a combination of mitigation and adaptation that will have to be looked at. I think this, along with what Pramod ji said, Dr. Pramod Aggarwal, in terms of risk reduction strategies becomes very important. And one of the things I would like to touch upon from our experience on the ground, where we tried to look at the reducing the vulnerabilities of farmers in 6 distress-prone districts of Maharashtra, that the risk reduction strategies, the risk that may accrue because of economic forces or that may accrue because of environmental forces, but it is a risk mitigation and resilience building and safety nets which have to be brought into the production system. It is not just providing insurance from outside. It is not just providing institutional framework for risk mitigation, but we have to have production system level risk management strategies. And therefore, looking at the farming system as a whole rather than the crop. So we looked at crop diversification, we looked at farming system diversification, which meant that there was a very important role for livestock to be brought in. as has been pointed out by so many. So this was one important thing. And what Pramodji mentioned about is that the reduced emission targets that we have are for the country as a whole. They are not for agriculture sector or for industry or for transport and so on. But what exactly that it points out is the non-specifying targets in terms of sectoral means that we have to actually have the opportunity of we're looking at intersectoral solutions which will make an impact on the overall emission levels that are there. And therefore, bundling of technologies, bundling of activities will probably play a very important role rather than looking only at agriculture or only at crops. I will give you an example from our own experience again. We are right now in the stage of working together with IIT Bombay to develop a technology and develop it as an enterprise solution for using cotton stalk, which is today burnt in the field. So it is a crop residue which is being burnt, how cotton stalk can be ozonized, and the ozonation process can make it more digestible. And then it can be mixed with cake, which can also come from, say, cotton seed. And then you produce a feed for the cattle out of that agriculture residue which was getting burned, and which becomes a very important input into livestock development. So you have that type of technology becoming imminent, and that is something which will have a very wide applicability. And what it means is that we are bringing circularity into the system. You are retracting from the burning of the crop residue, and we are putting it into a better usage, which is going to be for the growth of the sector, for the growth of the agriculture operations in that area. So the point is that the solution for a particular problem may lie in intersectoral aspects or intersectoral activities. So that is something which is also to be thought of. And that brings me to what Mario was talking about when he talked about the livestock sector. And he had a very interesting slide where he presented how we find that the emissions per unit production of milk go down with increased productivity of the livestock. So actually, if you look at the Indian scenario, we have a situation where we have two production systems in livestock, which is primarily dairy we are talking about. So you have a system where an intensive system of milk production, where there is a more precise feeding, more intensive feeding, and you have a higher level of production as well as a high productivity of animals. And you have a much larger numbered, almost 50% production aggregate level, a production system which is extensive, which is actually based on roughage feeding, and which is probably contributing more to the gas emissions. So but that also reaches out to large number of people. So one has to find a solution which will also reach out to all these people, but at the same time take care of the emission reduction. So we probably require two different pathways. One is in terms of better feeding practices, better balanced feeding in case of high intensive systems, and we have for the extensive systems to convert it into better circular pathways within agriculture and livestock as a nexus, so that you are able to deal with the agri problem in the crops as well as the problem in the soils. And of course, along with this, along with what Mario showed, it is also important to realize that the per production emissions per unit milk production goes down with productivity, but it also goes down with the number of the reduction in the number of unproductive animals. And we have that as a big problem in India, where we have a large number of male cattle who are not really contributing to the dairy sector, and who are becoming increasingly less important for the rest of the agriculture sector because of reduced requirements of transportation or traction or tillage. So as a result of that, probably imminent technologies like sorted semen become very important in the coming future. So we need to look at the livestock sector both from a technology perspective in terms of addressing the aggregate numbers, as well as two different feeding pathways for the intensive and for the extensive production systems that we have. But along with that, I would like to come to the point which Professor Ramesh said when he talked about combining mitigation and adaptation. And I think we have very refreshingly, very good pathways of that already demonstrated at scale in the country. For example, is what was mentioned by Harold and Andy when they talked about soil carbon. And one of the important things we know, which is actually the problem of soil depletion in the country, becomes an advantage because it is an opportunity to work on soil restoration and restorative practices which will increase the soil carbon, which is going to improve the agriculture productivity on the one hand, but at the same time it is going to lead to sequestration of carbon in the soils, leading to a mitigation impact. At the same time, if you look at the farming system as a production system, so we are not talking of agriculture production as a single crop system, we are talking of combining agriculture production with perennials, with tree crops. And if we have a tree crop based farming system, then we find that it is not only going to help in hedging of for the farmer, hedging of incomes, hedging against climate vagaries, against market fluctuations, but at the same time, it is going to sequester carbon because you have trees that are going to sequester whether above or below the ground biomass production. And we have a very strong program in BIF. We have implemented the WADI program since last 10-15 years, which has led to lakhs of farmers in the country being brought into this type of a farming system where you are combining mitigation and adaptation. This is one example. The other way is, of course, programs to improve soils. So I think we have these different pathways that are available. And what we need to do when we move forward towards the goals of zero hunger and zero carbon, that we are also looking at this to be combined with larger overarching goals, which will create a different economy, which is going to change agriculture from being just a food production system to a biomass production system. It will help us to move from fossil energy to bioenergy. It will help us to move from fossil-based feedstock for industry to plant-based feedstock for industry. So, we are probably at the threshold of creating an economy which is going to be a very solid, robust bioeconomy, where the farmer will not be producing only food, but he will have opportunity of earning his livelihood by producing so many other things out of his farm, not only energy, as Professor Ramesh was saying. It is not just as a urja data, but he can really be a data of so many other types of biomass. So I think these are things which I thought in a way cover most of the points that came out from the speakers. And I think I cannot do justice to all of them because they were such excellent points that were made. But I would like to stop here in the interest of time and give it back to Prabhu for addressing the questions. Thank you, Prabhu.
Thank you, Girish. That's an amazing job of trying to pull it all together. I thought it was impossible, but you made it possible. So thanks a lot. We obviously are running out of time, but I think it'll be useful to have at least some amount of discussion. There's several questions that were raised in the Q&A box and also in the chat box. I'm going to ask my colleagues, Misha and Matthew, to see if they can MC this part of the Q&A. And I mean, obviously we can't answer all the questions, but if you can pick a few and direct them to particular panelists, then we can get some discussion going.
Sure. Thank you, Prabhu. Yes, there are so many questions in chat box, through email, through Q&A box. I myself would have a lot of questions, but we don't have time. So we'll just need to be very brief. So there was a question for Professor Chand about minimizing crop distortions through agroclimatic crop regional planning is a welcome step. But the question is it feasible to implement that when there are some policy instruments like administered price distortions and input subsidies for farm energy, etc., which could distort efficient crop choices in terms of agroclimatic suitability? So I guess on one hand, you have policies in place and price-related policies, and then on the other hand, you have some other plans. So are they conflicting or can they work together?
You see, they are conflicting, no doubt, but we have to change them. If we have to address concern of sustainability, climate change, which concerns future of mankind, which concern future of fauna and flora, we have to change it. And already at the level of central government, there are some changes that rather than concentrating policy support only in favor of rice and wheat, you just find that it is now spreading to other products also. Earlier, we used to talk only about buffer stock of rice and wheat, but now we have a policy decision to create buffer stock of pulses of 2.5 million ton. Earlier, this procurement operation were, restricted to rice and wheat, but now they are expanded also to oil seeds, to pulses. So this policy support is no more so narrowly restricted or confined to rice wheat. It is gradually spreading, and many other options have also been given to the states, that if they want, they can try other kind of intervention for oilseed and pulses, and central government will bear the entire cost up to the 40% of value of procurement. So that is the kind of option given to the states. And but is now discouraging this diversification is there is a big hiatus between the technology level of development of technology in rice and wheat vis-a-vis other crops. I did a study in case of Punjab that even if you take away entire support from rice, don't give free water, don't give any subsidy on fertilizer, no crop come nearer to profitability of rice, even when entire support is withdrawn. So I think we also need to do a lot on R&D fronts. If during last 50 years, our soybean yield is stagnant, around 1 ton per hectare, it only fluctuates. Sometimes increase little bit, sometimes goes down little bit, but there is no trend at all in the last 50 years. Then how we can expect oil seed and crop like soybean to compete with say crop like kharif crop like rice, or even with cotton. So R&D is also important, policy support is also important, and now you just find that this emphasis is shifting.
Thank you very much. I think this was a very detailed and informative answer. Thank you.
So I must thank Andy, Harold, and Pramod Aggarwal for answering many of the questions in the Q&A chat box itself. But there was another question here which I can address, ask Andy and Harold to answer. So adaptation and mitigation strategies should take into account the ability of smallholders to implement them, without which many of this might be futile. So how do we ensure that both at the policy level and also at the implementation level, that many of these strategies can be addressed towards smallholder production?
Yeah, I'll give it a start. Some of the issues are or strategies can be universal. Some of them maybe need to be more tailored towards a particular production environment, whether that's a physical production environment or whether it's a socioeconomic production and environment. And I think that that is really a key component. I'm always a little concerned when people talk about packages, and this package is a solution. And I think we have to some extent focus on the principles and the processes. For example, higher biomass production and higher crop yields is beneficial. More input use in efficiencies, especially with nitrogen, is beneficial. And then you can apply those principles to the different production environments, but they're not always exactly the same. The smallholder farms may have more natural cycling of carbon, for example, because the livestock and the crops may be integrated. They maybe want to look more at alternative feed sources, maybe higher biomass crops, for example. But that would be different from a farm that might be a little larger. That's more cash grain, cash production oriented, and exports more of the grains or the other products off the farm. So I completely agree. You can't have a one size fits all, and that's what makes agriculture so unique. And that's not only in India. That it's very much dependent on the physical and the socioeconomic conditions that exist on a particular farm, and that's why, from my perspective, any sort of policy incentive needs to sort of account for these different conditions. But some I think strategies go well across all types of different production systems, but some others maybe do not. And so we need to work. Maybe the socioeconomic perspective hasn't been adequately addressed in this workshop, and so we maybe need to bring a little bit more of that perspective into it, and that partnership between people like us who look from maybe more agronomic or livestock oriented perspective to better sort of understanding how that translates to potential changes on the farm. So Andy, you want to add to that?
I agree with what you said, Harold, and just add that a lot of this comes down to prioritization and targeting, effective targeting, because if we come with packages or we come with too many messages, we overwhelm people. And so figuring out where there's really scope to drive these sustainability transitions is super important. And then paying attention for some things on value chains, you really need a comprehensive approach that looks at business and all those sorts of things. For knowledge products, we need to pay more attention to the way that messages are communicated, even when they're appropriately prioritized and targeted, so that we are coming across with simple messages that are actionable and that are conveying messages that really resonate with the way that farmers are making decisions.
Do we have time for one more question? It's a very interesting question.
Go ahead.
Sure. So a question for Girish Sohani. So given the importance of smallholder livestock production in meeting protein requirements of the population, what's your opinion on strengthening small ruminant-based livelihoods, and how should debate around livestock and climate change, how should it be framed?
Yeah, luckily, it so happens that most of the dairy production in the country is smallholder production. We have seen, for example, in a more progressive state like Maharashtra, you have a situation where, again, smallholder population has become very intensively dairy production oriented. So starting from 1 or 2 animals, they have gone to 8, 10 animals, primarily dairy production and not much of crop production. But in most of the other parts where there are smallholders who are producing milk, it is a very, very integrated farming system. So the dairy production goes together with crop production, and the crop production also leads to residue, which can become a feed that gets recycled through the livestock. But that is where probably a lot of work is required today to produce dual purpose crops, which would produce food as well as feed. And not so much, because in India, the smallholder cannot afford to have a separate piece of land for fodder production. So it is increasingly, more important to have a combination. And at the same time, it is equally important to have residue converted to feed. And those technologies probably need a fillip and a wider dissemination that is possible. At the same time, there are also a lot of possibilities of improving the smallholder economics as far as dairy husbandry is concerned by better systems of breeding, better systems not just of feeding but also of management of cattle. And these are things which probably can benefit with technological inputs, including those in IT. So there is a lot of possibility of improving the return to such farmers, smallholders I'm talking of, through services which are in the area of breeding as well as in the area of management of cattle. So I think there can be a number of different things which can be combined to have an impact on smallholder dairy production.
Thank you very much.
Are you guys done with questions?
So, considering the time constraint,
Yeah, maybe since some of those questions were already answered in the chat, we'll take them as answered. And if there are others, we can always put up something on our website with some responses to some of the questions, I think. Thank you very much to all of you, all the speakers. This was the excellent session that we had today. It basically raises all the complexities of trying to address zero hunger and zero carbon, and the need for looking at it, you know, from not just a multidisciplinary point of view, but also bringing the political economy angles and the operational realities of how do you actually implement a broader program that looks at zero hunger and zero carbon. I take the point that agriculture is a small part of the total emissions budget, and that focusing on agriculture rather than focusing on the bigger sources of emissions may not be the right approach. But I also believe that, as Harold said, we have a win-win opportunity here, because as we look at more efficient production systems, as we look at more sustainable production systems, as we look at better adaptation strategies, then we're also contributing to mitigation. And so thinking about it in that more holistic sense allows us to contribute to better climate solutions, and rather than just be focusing on agriculture from a mitigation point of view. So I think that's a really great outcome that comes from this discussion. As I mentioned at the start, this workshop was meant to provide a broader country level perspective and a more general perspective. But what we'd like to do from here on is to drill down to a state level and do a much more detailed assessment of what does it take to get to zero hunger, zero carbon at a state level. And we'd like to start that process soon. And for that, we are our candidate state that we'd like to start thinking about is Bihar. And it's something where gives us an opportunity to look at the farming systems in Bihar and think about what are the options for addressing this zero hunger, zero carbon for the various farming systems within the state, and think through how do you get from the technology solutions to making them politically feasible and operationally real. So please keep an eye on our website, and if you're interested in participating in further discussions, please let us know. And we look forward to continuing to present some of our results in fora like this, on webinars, and maybe COVID permitting, one day we can actually do it in person somewhere. Thank you all, and goodbye for now.